We'll be starting today with the introduction to this book, the C Programming Language Second Edition by Kernighan and Ritchie. C is a general purpose programming language. It has been closely associated with the Unix operating system where it was developed. So let us note down the points as we go. Associated with Unix. It has been closely associated with the Unix system where it was developed, since both the system and most of the programs that run on it are written in C. The language, however, is not tied to any one operating system or mission, and although it has been called a system programming language because it is useful for writing compilers and operating systems, it has been used equally well to write major programs in many different domains. So it is also called as a system programming language because it is used to write compilers and operating systems. For example, you might have heard of the famous programming language Python. Its compiler is written in C, and the language is also developed using C. It is called as CPython. Many of the important ideas of C stem from the language BCPL, developed by Martin Richards. So, BCPL was a programming language developed by Martin Richards. C is stem, the ideas of C are taken from BCPL. The influence of BCPL on C proceeded indirectly through the language B, which was written by Ken Thompson in 1970 for the first Unix system on the DEC PDP-7. These are some of the major names in computing world: Ken Thompson, Martin Richards. BCPL and B are typeless languages. Are typeless. What does typeless mean? By contrast, C provides a variety of data types. The fundamental types are characters, integers, floating point numbers of several sizes. So, on the other hand, C has a type. The data types include some of the data types that are there in C are integer, floating point, and character. In addition, there is a hierarchy of derived data types created with pointers, arrays, structures, and unions. These are the basic data types provided by the language. We also have derived data types, which are arrays, pointers, structures, and unions. Expressions are formed from operators and operands. Any expression, including an assignment or a function call, can be a statement. So expressions are Any expression or a function call is equal to a statement, and pointers provide for machine-independent address arithmetic. C provides the fundamental control flow constructions required for well-structured programs, statement grouping, decision-making, selecting one of the set of possible cases, looping with the termination test at the top or at the bottom, and early loop exit. We'll be looking at all of this later. S- Functions may return values of basic type structures, union, or pointers. Any function may be called recursively. Local variables are typically automatic or created anew with each invocation. Function definitions may not be nested, but variables may be declared in a block-structured fashion. The functions of a C program may exist in a separate source file that are compiled separately. Variables may be internal to a functional, external, but known only within a single source file or visible to the entire program. The pre-processing step performs macro substitution on program text, inclusion of the other source files, and conditional compilation. The keywords here is preprocessor. This performs a lot of during compilation, it performs macro and it also performs conditional compilation. Macro substitution in a program, we'll look at it later, but then if there is a macro, it will substitute it with the value. Conditional compilation is also in the conditional logic. If there is a way to reduce the program structure uh, by knowing the value of the conditional result, it will do it. We'll look at all of this later in detail. C is a relatively low level language. This characterization is not pejorative. It simply means that C deals with the same sort of objects that most computers do, namely characters, numbers, and addresses. These may be combined and moved about with the arithmetic and logical operators implemented by real machines. So when you say C is a low-level language, it doesn't mean it is a we're not degrading the language. It is more of low level in the sense there is a machine and machine can understand some language which humans don't speak. C is closely knit with the machine language because C has the data types and address operations which are more closely understood by machine than it is understood by humans, so it is a high level language, but it is also more understood by the machine. Address here means it is not the internet IP address or the home address which you live in. Address is the memory address which we are talking about, memory locations. C provides no operations to deal directly with composite objects such as character strings, sets, lists, or arrays. There is no operations that manipulate an entire array or string, although structures may be copied as a unit. The language does not define any storage allocation facility other than static definition and the stack discipline provided by the local variables of the functions. There is no heap or garbage collection. Finally, C itself provides no input-output facilities. There is no read or write statements, no built-in file access methods. All of these higher-level mechanisms must be provided by explicitly called functions. Most C implementations have included the reasonably standard collection of such functions. So what they mean here is for humans, we usually speak in sentences. For example, this whole thing is a sentence. It is a character string, as you say it in computing terms, or a set of characters. So why do they name string for a sentence that a human speaks? So it is each character fills a gap and this forms a sentence. Each character forms and fills the gaps and it is knit together by a string, and this whole thing is hence called a string. This is a character string. Each word is a character string. It is a set of characters. C does not provide operations to deal with. It deals with individual characters as we saw before because it is defined as a basic data type, but this whole string is not a basic data type. Similarly, lists and arrays. And C also does not provide input or output facilities. So it is important to know that the printf function, which we will look at later, which is one of the most widely used statements functions in C. It is not defined in the C language itself, rather it is defined as a function provided by the standard library. And this standard library is provided by the compiler manufacturers or the compilers. Similarly, C offers only straightforward single-thread control flow, tests, loops, grouping, and subprograms, but not multi-programming, parallel operations, synchronizations, or coroutines. So even if you have, let's say, um, most of your laptops are 4 core, 8 cores, which supports multi-programming, multi-threading, parallel operations. Each core can perform a each of the 4 cores can perform an operation at a single given time and parallelly. This is not possible using C because it is designed to be a single thread control flow program. Although the absence of some of these features may seem like a grave deficiency, you mean I have to call a function to compare two character strings? Keeping the language down to modest size has real benefits. Since C is relatively small, it can be described in a small space and learned quickly. So what do they mean by C is small? So the set of rules that make up the C language is limited, which means that a compiler which compiles the C language is of small size because it doesn't have to take into account every other rule. It only has to take into account the small set of rules that are there. So it can be described in a small space. It can be, and again, it goes back to the preface sentence statement which the authors made. C is not served by a big book. It is a small language and it is served by a small book. Since C is relatively small, it can be described in a small space and learned quickly. A programmer can reasonably expect to know and understand and indeed regularly use the entire language. For many years, the definition of C was the reference manual in the first edition of the C programming language. In 1983, the American National Standards Institute established a committee to provide a modern, comprehensive definition of C. The resulting definition, the ANSI standard or ANSI C, was completed late in 1988. Most of the features of the standard are already supported by modern compilers. The standard is based on the original reference manual. The language is relatively changed. One of the goals of the standard was to make sure that most existing programs would remain valid, or failing that the compilers could produce warnings of the new behavior. For most programmers, the most important change is the new syntax for declaring and defining function definitions. A function definition can now include a description of the arguments of the function. The definition syntax changes to match This extra information makes it much easier for compilers to detect errors caused by mismatched arguments. In our experience, it is a very useful addition to the language. There are other small-scale language changes, structure assignment and enumerations. There are other small-scale language changes. Structure assignment and enumerations which had been widely available are now officially part of the language. Floating point computations may now be done in a single precision. The properties of arithmetic, especially for unsigned types, are clarified. The preprocessor is more elaborate. Most of these changes will have only minor effects on most programmers. A second significant contribution of the standard is the definition of a library to accompany C. It specifies functions for accessing the operating system, for instance, to read and write files, formatted input and output, memory allocations, string manipulation, and the like. A collection of standard headers provides uniform access to the declarations of the functions and data types. Programs that use this library to interact with the host system are assured of a compatible behavior. Most of the library is closely modeled on the standard input-output library of the Unix system. This library was described in the first edition and has been widely used on the other systems as well. Again, most programmers will not see much change. Because the data types and control structures provided by C are supported directly by most compilers, the runtime library required to implement the self-contained programs is tiny. The runtime library is another keyword since what they are trying to say is the data types provided by C are also defined by most computers. Are defined by computers too. So the runtime library required to implement the self-contained programs is tiny. The standard library functions are only called explicitly so they can be avoided if they are not needed. Most can be written in C, and except for the operating system details they conceal, are themselves portable. Although C matches the capabilities of many computers, it is independent of any particular machine architecture. With a little care, it is easy to write portable programs, that is, programs that can be run without change on a variety of hardware. The standard makes portability issues explicit and prescribes a set of constants that characterize the machine on the program on which the program is run. So C is a portable language, and the compiler itself is also portable, with few modifications, of course. What this means is it is not dependent on the machine on which it is written. C is not a strongly typed language, but it has evolved. Its type checking has been strengthened. The original definition of C frowned on but permitted the interchange of pointers and integers. This has long since been eliminated, and the standard now requires proper declarations and explicit conversions that had already been enforced by good compilers. The new function declarations are another step in this direction. Compilers will warn of most type errors, and there is no automatic conversion of incompatible data types. Nevertheless, C retains the basic philosophy that programmers know what they are doing. It only requires that they state their intentions explicitly. C, like any other language, has its blemishes. Some of the operators have the wrong precedence, some parts of the syntax could be better. Nonetheless, C has proven to be an extremely effective and expressive language for a wide variety of programming applications. The book is organized as follows. Chapter 1 is a tutorial on the central part of the book of the C. The purpose is to get the reader started as quickly as possible since we strongly believe that the way to learn a new language is to write programs in it. The tutorial does assume a working knowledge of the basic elements of programming. There is no explanation of computers, of compilation, nor of the meaning of an expression like n is equal to n plus 1. So in this book, they are not trying to explain computers as how does a computer work. There are many videos on the same. How the compilation process works. Compilation process is a different topic. This is not related to the programming as such, but any C program which is written by a programmer needs to be compiled and converted into a machine language, machine code. And most of you would recognize the .exe or .exe files in Windows. These are the machine code which we get after compilation process. The programs we write get converted to this and this gets executed. This is a binary file with zeros and ones, which is dependent on the machine. Hence, whenever we go to a website to download a particular software, it asks if Windows, if Mac download this particular file. So those are the binary files which we need to execute depending on the machine. But these are what the author is trying to say is these are not relevant here. This book is only about the C programming language. Although we have tried where possible to show useful programming techniques, the book is not intended to be a reference work on data structures and algorithms. When forced to make a choice, we have concentrated on the language. Chapter 2 to 6 discuss various aspects of C in more detail and rather formally than does Chapter 1, although the emphasis is still on examples of complete programs rather than isolated fragments. Chapter 2 deals with the basic data types, operators, and expressions. Chapter 3 treats control flow, if else, which, while, for, etc. Chapter 4 covers functions and program structure, external variables, scope, rules, multiple source files, and so on, and also touches on the preprocessor. Chapter 5 discusses pointers and address arithmetic. Chapter 6 covers structures and unions. Chapter 7 describes the standard library which provides a common interface to the operating system. This library is defined by the ANSI standard and is meant to be supported on all machines that support C, so programs that use it for input, output, and other operating system can access can be moved from one system to another without change. Chapter 8 describes an interface between C programs and the Unix operating system, concentrating on input and output, the file system, the storage allocation. Although some of this chapter is specific to Unix systems, the programmers who also use other systems should still find useful material here, including some insight into how one version of the standard library is implemented and suggestions on portability. Appendix A contains a language reference manual. The official statement of the syntax and semantics of C is the ANSI standard itself. That document, however, is intended foremost for compiler writers. The reference manual given in this book conveys the definition of the language more concisely and without the same legalistic style. Appendix B is a summary of the standard library again for users rather than implementers. Appendix C is a short summary of changes from the original language. In cases of doubt, however, the standard and one's own compiler remains the final authorities of the language. So there is a ANSI standard which most compilers follow, but then it is still left to them. They have the freedom to define their own rules and regulations. So now we have completed the introduction part. Next we'll be looking into chapter